So this is another question. Actually, this is the fourth question which we are going to take related to equivalent capacitance calculation. Okay. So again we'll approach the circuit in the same way. We'll try to identify patterns of connection. Now this circuit can be a little bit confusing to start with, because for a beginner student it will be a little bit confusing where to start solving the circuit. So again, first of all, you have to find out the patterns of connection. Now these three capacitors at the extreme right, the 10 microfarad, the 20 microfarad and 30 microfarad, they are connected in parallel. Okay, this is actually connected in this way. Okay, this is 10, this is 20, this is 30, and then we have the subsequent. So the total capacitance, okay, these three capacitors, the total capacitance of these three capacitors combination will be simply the addition, that is 30 plus 20 plus 10, which will be 60 microfarad. Okay, so if we reduce this circuit up to this point, we'll get 60 microfarad. Okay, so let us do it. So this will be 60 microfarad. Then we have, now again let us just do it in one step. These two capacitors, 80 microfarad and 40 microfarad, okay, they are also connected in parallel. 80 microfarad and 40 microfarad. See this, 80 microfarad and 40 microfarad, they are connected in parallel, 80 and 40. So the total capacitance of this combination will be simply the addition, that is 120 microfarad. Okay, these two capacitors. So we can just replace it. Okay, this with these three capacitors with a 60 microfarad, and these two capacitors with a 120 microfarad equivalent capacitance. Okay. Now, then we have this 60 microfarad capacitor here. Then we have a 50 microfarad. Then we have a 12 microfarad. Then we have this 12 microfarad. This is A and this is B. Now we have reduced this circuit up to this much. Now again we have to identify patterns of connection. Look at these two capacitors, this 60 microfarad and this 60 microfarad. They are connected in series. There is an end-to-end connection pattern. Okay, this end is connected at this point and this end is connected to this end of the capacitance, means the right end, if we call it the right end of this capacitor, it is connected to the left end of 60 microfarad. Okay, then it is connected at this point. So in between these 2 points there are 2 capacitors connected in a end-to-end fashion. So the equivalent capacitance of these 2 capacitors will be C equivalent equal to 60 into 60 by 120. Okay, this is 2, this is 30. Okay, so let us just replace it with its equivalent capacitance. Okay, $30 microfarad, which we calculated here. Okay, now this 50 microfarad and this 30 microfarad, they are actually connected in parallel. they are connected in parallel, because this end of 50 microfarad capacitor and this end, the top end of the 30 microfarad capacitor, is connected at one common point, and the bottom ends, they are connected at one common point. So the equivalent capacitance of this combination of 50 microfarad and 30 microfarad will be simply the addition of these two capacitances, which will be 50 plus 30, which is equal to 80 microfarad. Okay, so let us just again redraw the circuit. It will be 80 microfarad. Now again, this 120 microfarad and this 80 microfarad, these two capacitors, they are connected in series. Okay, they are connected in series because there is an end-to-end connection pattern. Okay, this 120 microfarad and this 80 microfarad, they are connected in series. So, and all these connections are in with reference to the points A and B, because we have to find out the equivalent capacitance across the points A and B. Okay, so with reference to these 2 points, this 120 microfarad and 80 microfarad, they are in series. That's what I'm saying. Okay, the 120 microfarad and 80 microfarad, they are connected in series. So the equivalent capacitance, okay, let us just remove this. The equivalent capacitance is equal to 120 into 80 by 200. Okay, so this will be around this will be 4, this is 48 microfarad. Okay, this is 48 microfarad. So again, let us simplify the circuit and reduce it. This is 48 microfarad. Now again, this 12 microfarad and this 48 microfarad, they are in parallel. Okay, they are in parallel connection across the points A and B, because both of them have their top ends connected at one common point, bottom ends connected at one common point. So the equivalent capacitance will be simply 12 plus 48, which is equal to 60 microfarad. So let us just reduce it. It will be 60 microfarad. Okay, 60 microfarad. So just see how we are reducing the circuit. We started from this point, okay, from this point, and we have reached until this point. So you see, across this 12 microfarad, this portion, we have reduced it. How we have reduced, okay, up to this point. Up to this point, we have reduced it up to 60 microfarad. We have simplified the circuit into this 2 capacitor form, and that's what we have to do. Keep on identifying patterns between connection between these capacitors or resistors or inductors, whatever circuit element there is. Identify patterns of connection. Simplify by finding out the equivalent combination, be it capacitance, resistance or inductance. Again find out pattern until you arrive at a simpler form. Now the question which is asked, the find out the equivalent capacitance across CAB. This will be, because 12 microfarad and 60 microfarad, they are in series across A and B, because there is an end-to-end connection. It will be 60 into 12 by 12 plus 60, which is equal to 60 into 12 by 72. So this is getting 6 and this is 10. Okay, this is 10 microfarad. So the total equivalent capacitance across the point A and B is 10 microfarad. Okay, this is the answer. So in all of the questions that I have discussed related to calculation of equivalent capacitance or inductance or resistance, the concept is the same. We have to find out the patterns of connection between the various circuit elements. We have to start from one end, find out the patterns of connection, simplify it using by finding out the equivalent capacitance, then again find out the pattern, simplify it until you arrive at a simpler form, a 2 resistor or 2 inductor or 2 capacitor form. Okay, so this is the basic approach. So this is the fourth question related to calculation of equivalent capacitance. So let us take some more questions related to equivalent capacitance. Okay, I think until now we have discussed around 4 or 5 questions related to equivalent capacitance, and we'll take some more so that we get acquainted with this uh, idea of calculation of equivalent capacitance. Okay, it is very important because in more advanced circuit analysis, be it network theorems or AC network analysis, transient analysis, this equivalent capacitance, resistance, inductance, they will play a huge role. Okay, they will be very crucial in studying those things. Okay, so let us take some more questions. Okay.